Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at wire size customization in Design Master Electrical. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email with any questions you might have. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So today is going to be looking at the wire sizing customization in our electrical software. The easiest way to get to that is off the pull-down menus. I like to get all the customization from the pull-downs because it's a little easier to find stuff there. So under customization, we have wire sizing, and then we can modify what's active in the current project or edit the master list, which is what you use when you start new projects. For this training, we'll be looking at the project list. Run that command, and we get the wire sizing dialog box. And so this is where all of the information is set in Design Master Electrical to control the wires that you have available and which ones are chosen based upon the electrical design you've got going on. So we are going to first look at the wire size in the top middle here. And so this is a list of the wires that you can use. You can see that we've got a number of them built in. We have the default, which is assumed to be copper, and then the aluminum, which we call out with the AL there. There's a wire size label, and then there's also a schedule label. The wire size is what shows up in the callouts on the drawings, like your home run labels and whatnot. Schedule labels show up in the schedules if you have a wire size column in your fault schedule or your panel schedule. Not very many reasons to have those different, but at least one customer requested it at one point, so there they are. Generally, those are going to be the same thing. And then you have the wire area, which is the size of that specific wire. And then we use that wire area for calculating conduit fill. So by default, we include copper and aluminum wire number 12 up to 750, 800 kc mil. If you need additional wire sizes, you can add them there. Then we also have the conduit sizes. And here we have the just a list of all the conduit sizes, their areas, so how much space there is. And again, we use that for the conduit fill as well. So this is basically the inside clear area. The NEC has tables in the back that list these for the different types of conduits. So you can fill that out. And then we have a couple check boxes for whether that conduit is used as a standard conduit size on branch circuits or feeders. So if you want to eliminate half-inch conduit being used to be sized to automatically, there are two choices you could use for that, because that's a pretty common request. We don't use half-inch conduit. How do we get rid of it? You would delete it entirely. And so if you delete the conduit size, it'll be removed from the project. You can't use it anymore, and no one will use it, and it's just not going to get sized to. You can also leave it and uncheck these boxes. That will allow you, if you need to override it and choose half-inch conduit as a custom size, but otherwise the software is not going to size to it. And so what you do is a matter of preference. If you ever need to use that in some special cases where you've got an existing condition you're trying to model or something, and if you don't anticipate that, you can just delete it entirely, and then it won't be there at all. If you have different materials of conduits, this is the place where you would specify those. And the best way to do that is to add the new size and give it a label, say half-inch conduit. And then instead of the way we like to do this, and it's kind of up to you how you want to document it, rather than saying C, you could say PVC. So that's indicating half-inch PVC conduit. And then you could also do another one, half-inch EMT. So now you can choose specifically PVC or EMT. Typically, you kind of have your default in your spec, So that would be the one that you just labeled C for conduit, and then have the other one as the other option that you choose. Then you would want to go to the back of the NEC and look up those conduit areas and fill them in. It just copies the row above, so these are 12 inches, which is obviously way too large. So it's going to be put something closer to this. I don't remember if that 304 is PVC or EMT, and the other one would be a little different, but that's what you could choose. And then since we want to, for this example, maybe we want to size to our other one by default, but not to these ones, we can turn them off, and then it won't size to that automatically. Turn our half-inch back on. So that's how you can go about adding additional materials for your conduits. There's a little bit of work, because you got to put all the sizes in there, so there's a little bit of data entry. Do that in the master schedule, and then on future projects, it'll pull that master schedule in automatically for you. Then at the bottom of the dialog, we have kind of the meat of it, and these are the ampacities that Design Master uses for choosing specific wires. So you've got the amperage listed on the left, and so that's the either you're choosing a specific breaker and we need a wire size to match, or we're taking a look at the load and we're trying to find a wire configuration that match it. So you've got all the amperages listed there, and then for each ampacity we have the wire sizes that will be used when we have that size, when we need that size wire in the project. So the first is the wire size, and so that's your phase conductors. And you'll notice that we actually have, for 20 amps and everything, we have two options. At the 220s, we have both the regular, the copper, and then we also have the aluminum. So you can actually have multiple configurations for each ampacity. And then we'll see that basically over here, you've got checkboxes for which ones are the standard one that we size to if we need a 20 amp feeder, and then which one is basically you can choose to override it with. Moving along the columns, we've got the service ground and the equipment ground. That's used obviously for sizing the ground wire. Service ground is based upon NEC 10. If we go to our ground wires, NEC 250. So the service is 102, equipment is 122. And so when you're looking at your ground, you can choose to size to one of those options automatically, and we'll pull the column out. We also have the ability to size automatically, and what that's going to do is it's going to choose the service or the equipment grounds based upon what it's connected to. Basically, if it's connected to a transformer or to the utility, we will do a service ground, and then everything else uses an equipment ground. So if you have it set to size automatically, that ground size on this piece of equipment is going to change depending on what it is connected to. Then we have the number of parallel runs, and so this is the just the number of runs you have of conduit of similar size wires. All of these are set to 1 up here. We scroll down to the larger ampacities. You've got 2 and 3 runs of conduit. So that's assuming that you've got 2 runs of the number 4 wire, for example, and this is 450. And then we have the impedances, the X and the R, the reactance and the resistance values. Those are pulled from NEC Table 9. So you have to go back there in your NEC. If you would need to add another wire size, look them up. It has the resistance and the reactances listed. It depends on a couple things, type of conduit and whatnot. So you have to make sure that you're selecting the values. And that's what Design Master is actually going to use for its calculation purposes. All of the wire sizing, the number of runs and whatnot is for labeling purposes, but it's not actually used in the calculation. At the end of the day, this is what we base our calculation on. And those X and the R need to account for the number of runs. So if you have 2, you need to divide it by 2. If you have 3 or 4, divide it by the appropriate number of runs. Then we have the checkboxes for standard branch circuit, standard equipment branch circuit, and feeders. And what this is this is what will be used if you need a 20 amp circuit which one of these two options is going to be used in each of these cases. So you can size your branch circuits connected to your devices differently from your feeders, and then also a little bit differently from your equipment connections as well. And the equipment connections are there because there's some places where you want to have your equipment size automatically to some of the 25 and 35 amp breakers. Some people like to have that as a default when they're doing their equipment connections matched to MOCPs. So we added that as a separate from the just regular branch circuit. And you notice that when you do check it, we'll uncheck it from the other one in that same grouping, so you can only have one default for a 20 amp breaker, just because we need to know which one is the software going to use when it sizes automatically. And we have whether the wire configuration should include a conduit in it or not. If that's checked, we'll figure out the number of wires, their size, and choose a conduit size with a 40% fill for you. And finally, we have a description. If I make this just a little bigger, you can see it. And this is going to be added to it so that you can kind of tell which one you're choosing. So to demonstrate all of this, we'll come down here to this 400 amp, and we're going to make a new 400 amp breaker. Because by default, Design Master uses a single run of 600 kc mil wire. And a lot of people look at that and say that is too big. They would prefer to use 2 runs of 3/0. So we're going to create that as a second option. So we're going to change the wire size here to 3/0. And we'll have 2 runs, which I copied from that aluminum configuration up above. Match our ground sizes from the 200 amp column here, or row. And then the X and the R value need to set properly. So we have 2 runs of the number, the 3/0. So we know that a single run is 0.042, so we just divide that by 2, do 1, and then we do the 0.77, 0.385. So now we have the X and the R values appropriately set based upon the 2 runs of the 3/0 wire. And we'll leave this as not a standard configuration. So by default, we're going to size to the 600 kc mil still, but we have the option for the 3/0. And then we need the description. And you can type in anything you want here, whatever you want to have so that you know when you're choosing it that that's what it is. So I'll say 2, I can get my 2 3/0. So that we know that's the configuration with 2 3/0 wires. Click OK. If we pull up, say, a panel here for our conductor amps or anything, we now, not there. If we go to the upstream overcurrent protection, we have the 400 that we were looking at before. We have the 400 aluminum, and then we have the 400 configuration with 2 3/0 wires. So it added that new option for us. Use the description to differentiate it, so when we're choosing it, we know which one that we're looking at. So if we set it to 4/0, we get the 600 kc mil. We do the 2 3/0, we get the 2 runs of 3/0 wire. And if we set this to be the same as the main disconnect, this happens to be a 400 amp panel, and so it's going to choose that 400, the 600 kc mil configuration. We can go back to our wire sizing customization, and if we change that, it'll change it for that panel for us. So if we go to the 400, we say, okay, we actually want to use this as our default because we like this better. So we'll set it as the default. We actually have these buttons here to move it up and down. Maybe we want to have that at the top so that that one is the up at the top, and so it's clearly, you know, the one that you want to choose. Maybe even adjust our label so that this one here calls out that this is 600 kc mil configuration. It's kind of a weird one, so we'll call it out. If you want to use it, you can. Click OK. And now it's going to say, okay, you made some changes to your wire sizes. Do you want to recalculate everything? It takes a little while, which is why we asked before we do it. If you don't do it, it basically says you need to do this later using the calculate all circuit loads command. We'll say yes. It's going to take a moment, and it's going to do the calculation for us. This way that we can be confident that it's using the wire sizes that we've specified. So it's using the same as the main disconnect, and the trip is actually set to use that 600 kc mil one. So it's doing what we asked it to. We've specifically overridden this trip to use that 600 kc mil. If we set this to the same as the bus amps, now it sees it as just a standard 400, and it chooses the default 400 for us, which is the 2 runs of 3-aught wire. Also have the sizing options, which I skipped over here in the top left. This controls a set of choices for these standard checkboxes. So if I create a new option, let me call this aluminum, I can now make changes here, and it's going to be changed for this sizing option. So say, for example, we want our larger feeders to use the aluminum choices. We'll change this 400, we'll size that one, we'll say, okay, it's going to use the aluminum as its default. Same with the 450, same with the 500, and so on. If that's what we want to do, we'd go through and change the rest of those to all use the aluminum. So now if we choose the copper sizing option, size the copper wire for the big ones. If we choose the aluminum, we're going to, for the larger feeders, we would size to aluminum. And then we have the checkbox here. It controls which one of those options is current. And so mostly what you do is you'd set this up in your master if you have a couple different ways you like to size your wires. And then when you have a project, you can then choose which sizing option you like to use. So in this project, if I change it from this copper to this aluminum sizing, click OK, we're going to get the same question. Do you want to recalculate? Because I need to update with this new sizing option that you chose. It'll go through, and it'll see that 400 amp feeder on that panel, and it'll resize it the aluminum size now. And I had everything set up right, so it actually did pull it off and resized it correctly to aluminum. So that's what the sizing option is doing. If you go into the master list, we have those options again. Let's put a couple in there. It doesn't have the checkbox for the current because it's just in the master, so there is no current choice. That is actually the end of what we have for wire size customization. So if anyone watching has any questions, you can go ahead and type them into the chat box. If anyone viewing the recording has a question, you can always call us at 866-516-9497 or send an email to support@designmaster.biz. So if anyone does have a question, go ahead and type it in. While we're waiting for those to be typed in, I'm going to go to our mailbag and to look at some of the questions that we've had asked of us recently. Most of these are general support questions. People were having a specific problem, and that we thought that the question and answer was relevant enough to share with other people. So we're going to take a look at some of these other questions that people have asked us. The first question was someone they had trying to connect multiple panels off of a single breaker in a switchboard. They wanted to know how to do that with our software. Let's go ahead and set that scenario up. We can create our switchboard, and we'll create 2 new panels. Call one A and call panel B. So we want to have A and B both fed from the same breaker on the switchboard. If we go to our connect distribution equipment command, take panel A, take our switchboard, connect it to circuit 1 there. Then we take panel B, connect it to the switchboard. Circuit 1 is no longer an option. So what's going on is you can actually only connect in Design Master a single panel to breaker. So we don't directly allow you to do this, and that's why the question was asked. They're saying, okay, I'm trying to do it, and the breaker's gone. What do you do? Now, the way that you model that with our software is that you need to create another piece of equipment between the switchboard and the panels. Typically, the enclosed breaker disconnect of our catch-all for things of this nature. You can use pretty much anything, but if we put our breaker in there, we'll just call this a breaker. So we have now this enclosed breaker, this disconnect. Basically, it's another piece of equipment we can connect things to. And we'll set it to have 2 taps, 2 connection points. And so now we can take that panel A. I'm going to connect it, disconnect it basically to get it off that breaker. Take the closed breaker we created. I'll connect that to the switchboard. And then I can take panel A, connect it to circuit 1 on that breaker, panel B, and connect it to circuit 2. And so that is how, in Design Master, you go about making those connections. And then if we look at what the tree ends up looking like, so we've got switchboard, the breaker, and then A and B connected to that. When you view your fault and voltage drop, that breaker is going to show up. So if I update, actually I'm going to just update everything to have it show up everywhere it should. So ignoring the fact that it's got the X, and that's because it can't calculate the feeder length because nothing's been inserted, you'll see that you've got switchboard, and then you've got the breaker, and then A and B. Same with voltage drop. And actually, if we do the 1 line for it, you'll get the same thing as well. And you don't necessarily want to see that because it's kind of a piece that you're using just for modeling purposes, and it's not actually something that you want to have called out quite that explicitly in the project. What you can do is go back to the breaker definition, and underneath schedule settings, we have checkboxes to display or not display items in each of those schedules. So I could turn it off basically everywhere. And now, when I run my update, it's going to remove that from all of those locations. So it actually removed it from the 1-line diagram because we asked it not to show, and it connected the 2 panels to the switchboard. The fault current schedule, it looks like A and B are directly connected to switchboard. Same with the voltage drop. So that would be how you go about connecting multiple pieces of equipment to the same breaker. Another question that came in is, how do I disconnect a panel so I can connect it to something else? And in general, with Design Master, don't ever really need to disconnect something. You just connect it to where it belongs, and Design Master will do the disconnecting as appropriate. We have the disconnect options, and like I was just showing you, if you need to clear up the space because you want to put something else there and you don't know where it's going to go, you can just disconnect it. But you only disconnect it if you want to just park it not connected to anything for a little while. If you know exactly where you're going to connect it to as the next step, skip the disconnect idea and just go straight to the connection. For example, if we take the breaker that we were looking at just before, it's connected to the switchboard, it's connected to circuit 1. If we wanted to actually connect it to circuit 10, we don't need to disconnect it and reconnect it. We just select 10, press connect, and now it's connected to the new circuit. There's nothing else required to make that happen. Branch circuit and devices work the same way. So if we come over to here, we've got this air handler on L2, 10, 12. If we want to connect that to something different, so we want to connect it to panel L1, there's no need. We could go to L2, and then we actually have on-circuit devices where you can select. If we do that, it'll just connect it. But if we know we're going to connect it to L1, we can just go to L1, select circuit 1, select the piece of equipment, and it'll make the new connection, and also disconnect it from the other panel as well. So now we've got the space there where it was previously connected. Another question we had was related to switching and looping. So someone had some light fixtures laid out, and they connected switches to them, which we actually have set up over here where these switches are connected to these light fixtures. And the automatic loops that Design Master put in weren't quite right. So let's go ahead and make that happen. I'm going to connect, circuit all of this up, put both of those switches on the same circuit, draw the home run. Design Master puts its loops in, and it does its best, but the loops that it puts in are not always going to be the loops that you would have put in. In this example, this switch is controlling this light fixture, so it's connected. But the switch is actually controlling these other light fixtures here in the middle. And it chose to connect the two switches together. Maybe you don't want to do it that way, but you'd prefer to have the loop run straight to the light fixture it's controlling. The way to handle that is to do the loops, have Design Master put them in. Notice that you're not happy with them. And then manually get rid of the ones you don't. So we'll get rid of this loop here. And then use the loop devices manually command to add that loop back in. So we'll just say, okay, let's connect this way. So the answer is, Design Master is not always going to put the loops in exactly correctly. We do our best, but it's just never going to match exactly always what you want it to do. So rather than trying to figure out a way to make it automatically read your mind, just come in and tell it what you wanted instead. You will notice, though, that this new loop doesn't have any tick marks, and some of these other tick marks aren't right because it's no longer connected to that switch. So once you have all of your loops done, you then need to come back and you can run the draw tick marks command. You run that, you select any device on that circuit, and it'll redraw all of the ticks for you. So it kind of takes a look at the loops you have and figures out where the tick marks should be and puts them back in. That's how you get it to update the tick marks. So if you are using tick marks and you want to get those updated, run that command. Also have the insert tick marks command, which you can use to put in tick marks manually. You generally don't want to do that because it's very tedious, among other things. So the draw tick marks command will actually put them back in automatically for you. And that is it for questions from the mailbag today. If anyone watching live has any questions, you can type them in the chat box. Anyone viewing the recording later, go ahead and give us a call. Our number is 866-516-9497. You can also email support@designmaster.biz.